Okay, here we are with our Unit 1 test review for Alg 2. Hopefully everybody does well. This list you've been given, you also have a review sheet. It would be a good idea to take notes on that. You are not allowed to use your toolkit. Number 1 is going to be about function machines. Number 2, investigating functions. 3, operations with functions. 4, systems of equations. 5, solving equations. 6, linear web. 7 is also linear web. Some of them are a little bit different there. 8, quadratics, and 9, right triangle trig. Now, in this session, we're only going to review a few of those major topics. The others will be up to you to prepare yourself accordingly. First thing we're going to look at is investigating functions. So let's say that we're charged with investigating the function x squared plus 4x minus 12. Step 1 will be to make sure that your list of items included in an investigation is complete. That list would include an XY table, x-intercept or intercepts, y-intercept, vertex or other special points. We have domain, we have range. We're also looking for any horizontal or vertical asymptotes. We need to determine if it is a function. Okay, and I think that's going to be about it for now. Oh, most important part, the graph. So where to begin, that's entirely up to you. Obviously, the graphing calculator is a great resource for this particular type of problem. So it wouldn't be a bad idea to use that to be able to graph. All right, so for those of you that are using the calculator, you just want to go in, in x squared plus 4x and minus 12, and that will give you a graph of that calculator. Now, for some reason, your screen doesn't give you the whole picture, which this one does not. Then you want to use the window function and adjust the window accordingly so that all important points are going to be on your particular function. Whoops, changed the wrong one there. I don't want that. I want like this to be negative 15. And that should include all the important points. Oh, vertex is still off. So let's go down to negative 20 and see how that looks. So that gives us all the important points of our particular function. Now, there are other ways to go about doing that. So I'm going to show you some of those algebraic ways. First step would be, you could just find the table. But typically what I'll tell people do is find the vertex first. Now, the vertex can be found by taking the opposite of b over 2a if you didn't know that. So opposite of b, so that's negative 4 divided by 2 times 1. So our x value of negative 2 is where our vertex will happen. So then I just substitute negative 2, might as well make that one of my table values, into the function and determine the y value. So negative 2 squared is 4. 4 times negative 2 is negative 8. So 4 and negative 8 make negative 4. Negative 4 minus 12 is negative 16. So that is my first point, okay, on this particular graph. So negative 2, negative 16. I'm going to have to count by 2's on the y-axis. That's my vertex. All right, now, I could also find my x-intercepts by doing a little bit of algebra. I would want to see if this is factorable, and if it is, then that will tell me my x-intercepts. So x and x, 2 numbers to multiply to give me negative 12, so that when I add, I get 4, and that's going to be a positive 6 and a negative 2. Therefore, my x-intercepts end up being negative 6 and positive 2. Now, if I substitute those, I should be getting 0. It wouldn't be a bad idea just to check that. 2 squared is 4. 4 times 2 is 8. Okay, 8 plus 4 is 12. 12 minus 12 is 0. Check. So 2, 0 is one of those intercepts, and negative 6, 0 is the other one of those intercepts. All right. Now, a unique part about quadratics that do not have a stretch factor is that from the vertex, they always work the same, over 1 up 1, over 1 up 1, over 2 up 4, because 2 squared is 4, over 2 up 4, because 2 squared is 4, so on and so forth. Okay? Oh, almost forgot that I'm counting by 2's. So over 1 up 1, over 1 up 1, over 2 up 4, over 2 up 4, over 3 up 9, because 3 squared is 9. 2, 4, 6, 8, 9, and 9. And then over 4 should be up 16, and then I have my graph. Just make sure on the test that if you do count by some number other than 1, that you notate that somehow on your coordinate plane. So now I have a table. You know, I can put, as long as I have a few values in there, I'm okay. It looks like my y-intercept is going to be 0, negative 12. So I'm starting to fill in some of these pieces here of my investigation. So xy table I have. X-intercepts I found to be negative 6, 0, and 2, 0. Y-intercept I just found to be 0, negative 12. Here's my y-intercept. Here are my x-intercepts. Vertex, I did find the x value of that, and to plot the point I had to find the y value, which ended up being negative 16. So that's my vertex. Now for domain and range, domain, because it is a function and it's a continuous function, it goes on forever in both directions, left and right. Okay, so forever to the left is negative infinity, forever to the right is infinity. So I can write my domain as an inequality. I could write my domain using the all real number symbol. Range is a little different. These arrows do go up forever, both directions. So up forever is infinity. However, they do have a lowest point, in this particular case, negative 16. So I can write my range two different ways. I can write it as a compound inequality, negative 16, y is greater than or equal to, and then less than infinity. Or I could write it using the all real number symbol, greater than or equal to negative 16. There's no discontinuities in this particular function. So there are no horizontal or vertical asymptotes. It is a function. Let me tell you something real quick. If your graphing calculator is able to graph it, in which case ours was, then it has to be a function. Yes. But the other reason is that it passes, the graph passes what we call the vertical line test, which means that there's no vertical line that you can draw, okay, that intersects this graph, more than one time. Okay, I'm not sure why it's not letting me drag the whole line, just pieces of it. But you get the idea. Okay? And then I graphed it. So that would be your most complete investigation there for this particular parabola. Moving on. Function operations. So that just means I give you a function and you do certain things with them. In this particular case, we're going to substitute values and evaluate. However, it is possible to add functions together, to subtract functions, multiply functions, and also apply function composition. So for this first test, though, we're going to keep it simple. H of x is my defined function, x squared minus 3x minus 10. If I'm looking for h of 2, that just means I'm substituting 2 in place of x. So I'm going to have 2 squared minus 3 times 2 minus 10. Now you can obviously use a calculator for this, and the hint would be that if you are going to, you must use parentheses. You'll see why in part B. However, you could also do the math. 2 times 2 is 4, minus 6, minus 10. Okay, so 4 and minus 6 is negative 2. Negative 2 minus 10 is negative 12. Best answer. And h of negative 1, now I'm substituting negative 1 into my function. And here's where I wanted to demonstrate for you what happens if you don't do this correctly on the calculator. So if I would just type negative 1 squared, okay, minus, 3 times negative 1 minus 10, all right, I get negative 8 as my answer. Everybody says, oh, a calculator did it, must be correct. However, when I use parentheses, I notice a difference, and parentheses is the preferred method here, and by preferred I mean correct. I notice that my answer is different. It is negative 6, and that is because the calculator, okay, will take negative 1, or take 1 squared, which is 1, and then apply the negative. It's following order of operations to a T. So you got to outsmart it by grouping the negative with the 1 using parentheses. So negative 6 is the best answer. And of course, you could always do it by hand. Negative 1 squared is 1, negative 3 and negative 1 is 3, and minus 10. So 4 minus 10 is negative 6. The last one here is one that some people struggle with, a plus 1. That means we're plugging a plus 1 in its entirety into the function in place of x. So it would look like this. A plus 1 squared minus 3 times a plus 1 minus 10. And now for the part that really hangs people up, and that is how to go about squaring a plus 1. Way too many people think that you just square each of them. A squared, 1 squared. That is not true. There is no distributive property for exponents. To square a binomial, okay, this is sort of as an addendum here, to square this, it should be a plus 1 times a plus 1, which means you can either use FOIL or the generic rectangle. I don't care. Choose an appropriate method. Do not distribute the two. That is not how it works. However, there is a shortcut for squaring binomials, and that is square, double, square. Let me explain. Square double square means square the first one, so a squared, double the product, so the product of a and 1 is a, double that, 2a, square the last number, 1. Square double square. Use the method that you prefer, as long as it's correct. Distribute the negative 3, so negative 3a, minus 3, minus 10. And then I simplify. A squared is the only a squared, so it stays by itself. 2a and minus 3a makes minus 1a. 1 and negative 3 makes negative 2. Negative 2 and negative 10 makes negative 12. So that would be my final answer. There will be a's in your answer because there is an a in the original problem. Next, we have systems of equations. Again, this should be reviewed from Alj A and Alj B. There are many methods to do this. You could use the graphing method, which is ideal when y is by itself. Y is not by itself, so graphing method is not ideal. You could use equal values method when you have the same variable by itself in both equations, then you let the two equations equal to each other. However, the same variable, neither variable is by itself in this particular, so that wouldn't be the best. You could use substitution, which is best whenever you have a variable by itself in one of the two equations. We do not have that. Therefore, substitution is not the best method. And finally, is elimination method, which is ideal when you don't have any variables by themselves, but it may appear mildly easy to just multiply by a certain number so that you have opposites, top and bottom. Therefore, when you add the two equations together, a variable cancels out. So I'm going to choose elimination. Now I could eliminate x or y. It doesn't matter. It's entirely up to you. I'm going to multiply this one here by negative 2 so I can eliminate the x. So if I distribute that negative 2 to everything, I end up with negative 2x plus 2y equals negative 14. Now I'm considering that with my original first equation. I add them together, and this is what I was looking for. Positive 2x, negative 2x makes 0. Therefore, there are no more x's. Positive 2y and negative y make positive 1y. And negative 14, 9 make negative 5. So y equals negative 5. Once I have solved for one of those variables, I take it and I substitute it back into the original equation and solve for the second variable. So 2x minus negative 5, don't forget it's a minus a negative, equals 9. Minus a negative is equivalent to adding, so 2x plus 5 equals 9. And then I would just want to solve this equation for x. So 2x equals 4, divide by 2, x equals 2. Am I finished yet? No. The best way to represent this answer is as an ordered pair, because that ordered pair, or this answer, represents where those two lines intersect. Linear web, so this is a little review from Alj, that's a long time ago. Given the partial table below, find the following. Find a graph, a table, or rule in a situation. There's many different ways to go about doing this. For those of you that aren't real strong in your algebra skills, the easiest method would probably be to plot the 2 points, negative 3 and negative 3, 3 and 9. Draw the line connecting those 2 points. and then use your graph to write the equation of the line. So I would need to observe that this graph intersects the y-axis at 3, and I would need to observe that it goes up 2 over 1, okay, for its slope. Therefore, my equation, or my rule for this would be y equals 2x plus 3. Keep in mind, the calculator is always a valid method. I can go into the calculator, okay, and if I go to Stat, Edit, if there's numbers in my list, clear them out by highlighting the list number and hitting Clear. Type my x values into L1. My x values here are -3 and 3. Type my y values into L2, which are -3 and 9. Just make sure they correspond. 3, 9, -3, 9, -3, 3. Quit, so second, quit. Stat again. Calculate linear regression. Enter. And it gives me, y equals ax plus b instead of mx plus b, but a is 2, b is 3, which is already the information that I found here. Slope is 2, y-intercept is 3. Okay. Fill in the rest of the table. So what is that? -4 plus 3 is -1, 3, and 5. And write a situation. So let's say, for instance, that Freddie starts the week with $3 and saves his lunch money each day. Quadratics review. Particularly finding the roots of quadratics. Use any method. Any method means you can graph to find the roots. Now, those will only reveal real roots, okay, or x-intercepts. We can use quadratic formula, and we can factor. Okay? Factoring also only reveals the real roots. So if factoring doesn't work and you graph it and the parabola doesn't intersect the x-axis, then that means we probably should refer to quadratic formula because the roots would be imaginary. However, Mr. Warner is going to go easy on you for the first test, and this not only is factorable, but it also has real roots, and it could be graphed to find this. I'm going to factor it. Now, you can use any method you want to factor this. I'm going to display for you the CPM method, which tells us to put our a value in the bottom left corner, 2x squared, our c value in the upper right corner, -15, and our b value in the bottom of the diamond. The top of the diamond comes from multiplying these two together. So 2 and -15 make -30x squared. And then I'm asking myself this question: are there two numbers I can multiply together? All right. That equal -30, and when I add, I get 7. And the answer is, of course, yes. And those two numbers must be 10x and -3x. The 10 is the positive number because the 7 is positive. So I fill those pieces into my table here. So it was 10x and -3x. So I fill those pieces into my generic rectangle, 10x minus 3x. Then I fill in the outside of my rectangle, so 2x and x. I place the 2 here because 2 times 5 gives me 10. If I'd have placed it here, it'd be a little tricky to get the -3. X times -3 gives me the -3x. And then I write my quadratic as a product. And it is the product of x plus 5 and 2x minus 3. I set those equal to 0 to solve for the roots. So x plus 5 equals 0. 2x minus 3 equals 0. So x is -5. And over here, x is 3/2 or 1.5. That's entirely up to you. Now remember, these are coordinates. They're the x-intercepts. So -5, 0, and 1.50. Right triangle trigonometry. This is a little geometry review here. So solve the following triangles for the indicated variables. Having the sine, cosine, tangent notes in your toolkit is going to be very helpful. The hint that I offer students is always put yourself where the angle is. Doesn't matter what the problem's asking for. All right, if it gives you an angle, put yourself where the angle is. Then label your sides. Well, the hypotenuse is always the hypotenuse. Based on where your angle is, this is opposite, and this is adjacent. So we're looking for the trig ratio that involves opposite and hypotenuse. That would be sine. The sine of an angle equals opposite over hypotenuse. Now I fill in the blanks. I know the angle is 15, so the sine of 15 equals x, opposite, over 5 hypotenuse. To solve this, I turn it into a proportion and cross multiply. So 1 times x is x, 5 times sine of 15. I will need to rely on the calculator. Now, one small note is that in your calculator, make sure the mode of your calculator is set for degrees. If it is not, you will not get the right answer. 5 times the sine of 15, and I get 1.29. So x equals 1.29. My second triangle here gives me 5, which is a leg, gives me 7, which is a hypotenuse, and it's asking for y, which is another leg. No angles. No angles means no trig. Okay? So what that actually means is Pythagorean theorem. A squared plus b squared equals c squared. Now the only tricky part about the Pythagorean theorem is to remember that the hypotenuse must be c. All right? So we end up with 5 squared plus y squared equals 7 squared. So 25 and 49. So y squared, I subtract this from over here, is going to end up being 24. And then I square root both sides. Now, here's where we get a couple different variations of the answer. Y equals the square root of 24. That's not the most simplified answer. That'd be like giving 4/8 as your answer to an equation, when in reality you should have reduced it to 1/2. So I can reduce the square root of 24 by breaking it up into 4 times 6, because 4 times 6 is 24. The reason I do that is because I know the square root of 4. The square root of 4 is 2. I don't know the square root of 6, so it's sort of like a remainder. So 2 root 6 is the best answer. However, I don't know if we are all there yet. So finding the square root of 24 as a decimal, 4.8989, so that's going to round to 4.90, is also a valid method for now. Best answer. Valid answer. Last, right triangle trig, locate the angle. This time the angle is the variable. That's okay. Label my sides. Hypotenuse is always across in the 90. Opposite of where I'm at is opposite. Next to where I'm at is adjacent. So I'm looking for the trig ratio that involves opposite and adjacent. In that case, we're talking about tangent. Tangent of an angle equals opposite over adjacent. Therefore, tangent of x equals 3 over 6. Now, if I'm looking for the tangent of an angle, I'm looking for the angle. That's where inverse tangent or second tangent comes into play. Only when you're looking for an angle do you need to use the inverse of a trig ratio. So second tangent gives me the inverse of tangent. 3 over 6, enter. And I get my degree measure, which is 26.6. So x equals 26.6 degrees. And that's it for our review session. And good luck on studying for the Chapter 1 individual test.